So let's start for our second revision here in lesson 6, which was talking about permutation and combination. We said what's the difference between the multiplication counting principle and the other type of select. Now, your friends rented 6 different video games. In how many different order can you play the 6 games? Here, what did you want to find? Here, I asked you now to, I don't tell you as an example, you have video games and you have song games or video songs or video CDs. Here, I have only one thing. I want you now to find or to select from these six of them, but in order. So, since I'm asking you to select 6 of the CDs games from the 6 in order, so I need to use permutation or combination. If I want to select a number of things from the whole, so permutation or combination. Then my second question, is the order here is important?
Yes.
They say yes. In how many different orders can you play the 6 games? So yes, the order is important. So because of that, I will say I need to find the permutation of how many videos we have. We have 6, and I need to put 6. So there will be permutation of 6 from 6. Now the second one, there are 20 games to choose from at the local game store. So here you have 20 games only to choose. So only I'm talking about games. So I could use permutation or combination. In how many different sets of 4 games you could you choose to rent? So here you have 20. You need to choose 4 of them. So what will you use? Permutation or combination?
Combination.
Combination. I told you here that you have to order.
No.
If I order, no. If I don't give them any specific job, so I will use the combination. But if I give them, like the first one is an manager, the second one is an pre-manager, the third one is secretary. So such I give them a specific job, this will be permutation. If there's no order, if there's no specific job, I will use the combination of 4 from 20. Now, do you have any question now here for lesson 6? Yeah. Now let's go to lesson 7. In lesson 7 here, our lesson was talking about theoretical and experimental probability. We say that, as you see, we have 2 types of probability, theoretical and experimental. The experimental is the number of times event occur over the number of times the experiment is done. So from its name, experimentally, so I need to make it. I need to do it as an activity by asking questions, by making an experiment, by making a survey. I will ask the students, or I ask the specific number of people my specific question in order to answer or to find how many or what's the number of video games you play in hour or during a day, as an example. So this is an experiment probability. The theoretical, no. The theoretical, like you have an exact dice, you have a number, you have such as a spinner. So if you look at it, spinner is divided into 12 sectors. So that means I could use 1, 2, 3, 4, 12, 6 or 12. So this will be theoretical. And its events will be, or its probability will be the number of favorable outcomes over the number of possible outcomes. Now, let's have this example here. Now, how do you, I not ask you, if this is experimental or theoretical? Yeah, both of them have the same formula. Now, you spin a spinner that has 8 equal sized sections, numbered from 1 to 8. So here I have a spinner. This is here now my spinner. And my spinner now, it is cutting into 8 parts. And they equally likely. They are equal sized. That means they are equally likely. Now then, they have a numbers like 1, 2, 3, 4, 5, 6, 7, and 8. Now, find each probability. Number 1, probability of getting number 7. So here, how many 7 I have? I have only 1 7. So I will say only 1. How many equal size, or how many sections we have here?
8.
8.
8.
I will say 1 over 8. Now, number 2, the probability of odd number. Odd. What's the meaning of odd? Odd, as I told you before, odd, it's mean 1, 3, 5, 7, and so on. Even 2, 4, 6, 8, and so on. The prime, like 2, 3, 5, 7, 11, 13, 17, and so on. That the numbers cannot be divided in or only in 1 or itself. Be careful, 0 and 1 are not prime number. Now, let's start here. So what is the probability of odd number? Odd number, as I told you,
4 over 8.
1, or 3, or 5, or 7. So I have 4 numbers over 8. Now, number 3, what is the probability of not 2?
7 over 8.
Yes, 7 over 8.
It is 7 over 8. How can I solve it? Either I count all the numbers that are 7, or I can find that the probability of all of them is 1 minus the probability of probability of getting 2 will be the probability of not 2. I mean 1 minus 1 over 8 will be 7 over 8. This is another way. Number 4, probability of less than 6. How many numbers are less than 6?
5.
5. So I
5
have
over
5
8.
numbers over 8. Now, how many numbers? They are a multiple of 2.
4 over 8. 4 over
Yes,
8.
miss, 4 over 8.
We can have 2, 4, 6, or 8. So we have 4 over 8. Now, how many numbers? And they are less than 9.
8 over 8
over
equal
8.
over 8.
We have
Equal
all the numbers,
Be 1.
which is 1.
1.
That's it. Is it clear?
Yes,
Yes,
miss.
teacher.
Yes,
Okay.
teacher.
Now, let's now talk about our last lesson, which is the probability of compound events. As I told you, compound events, it's mean I'm talking about two events or 3 events that they are combined in one event. Its name is compound events. In this lesson here, we deal with probability of 7, probability of less than 6. So I'm dealing with a single event, only one event. But the compound events, they are 2 events combined in one event. We call it compound events, such as a coin. You will throw a coin and you toss a coin and you throw a number cube. I have 2 events, so we call it compound events. Now, in order to combine between the combined events, so the compound events here are 2 events or more that I combine between them. Now, when I combine between them, I can use or I can use and. I can say event A or events B, or events A and events B. So I can say if I want to combine between them, I either use and or. Now, if I use and, I say event A and event B. When I use and, I will classify the events into dependent and independent. And if I use or, I can classify them in mutually and not mutually, or we call it overlapping. So, for what is the meaning of dependent events? A dependent event. Dependent events, from its name, that the first event depends on the second one. Like probability of getting red, then yellow. Probability of getting 4, then 7. Without replacement. I mean, like I choose the first ball, I take it red. I didn't replace it. I keep it in my mind. Then I choose the second one. I have now 7 balls. As an example, we have 8 at the beginning. When I choose one of them, I have 7 now left. So when I want to choose from the others, I look at my jar. I found only 7 are left. When I take the second one, I have 6 left. So the number of, or the probability of taking the fifth one depends on the probability of the previous balls that I got it before. That name is dependent. Now the independent. The independent means that I toss a coin or play with a number cube. Both of them didn't depend on each other. Or if you play with a jar of jam, you want balls, you want to play, or you want to get a balls, but with replacement. It means when you choose the first one, you look at it, you say it's red, you record it, then you get it back. So this will be independent, because if I take the same ball next time, it doesn't matter. But on the dependent, no. If I choose the red, maybe there's no red left. These are the difference between the dependent and the independent events. Now the second one, if I want now to combine between the two events, I can use or. In order to use or, I can say that I have 2 types of events, mutually and overlapping. Mutually means that there's no common outcome. As an example here, I ask you now, tell me which is your favorite language. One of you say Spanish. One of you say Arabic. One of you say English, as an example. So here now, when I ask you the probability of getting Spanish, we have 5. Here we have 6. Here we have 8. So there's no girls that they are common that they say Spanish or Arabic or Spanish and English. Since there's no common outcome, I say that these are mutually exclusive. Another example, like when I count how many girls in grade 8 and how many girls in grade 9. Now, in grade 8, we have 15 girls. In grade 9, we have 20 girls. So either you can be in grade 8 or in grade 9. You cannot be at grade 8 and grade 9 at the same time. This is, we call it mutually. Now, the second one, an overlapping events. Overlapping, like if you have now, or you have a common outcome between 2 things. As an example now, I ask you, what is your favorite color? One of you say red. I ask you now to choose 2 colors. One of say red, one of say yellow and black. So one of them say red and yellow. So the red and yellow can be in common. That's some of them say I like red and yellow, so they are in common. So we call it overlapping events. Now, what is the formula of it? The formula of OR will be probability of A plus probability of B minus the probability of A and B at the same time. But if there's mutually, I will have the same formula. But since they are no common outcome, so this will be 0. So I will say it is the probability of A plus the probability of B. Now remember, or and probability, yes, it's mean plus. And in the probability, it's mean multiply, as we said here. Let's start now with our examples here. Now here, you spin a spinner that has 8 equal sized sections. So here now, we have a spinner. And this spinner now is cutting into 8 sized equal sections. And they are equally likely, they are cutting into equal parts. Now, look at here. I asked you now 2 or 4. So what is my question? It's not the probability of 2. If I'm asking you about the probability of 2, this will be a single event. But probability of 2 or 4, so I combine 2 events now. So that's why I call it compound events. Now, the probability of 2 or 4. Of 2 or 4. Now, what is the probability of 2 or 4? The formula is probability of 2 plus the probability of 4 minus the probability of 2 and 4. Now, what is the probability of 2?
1/8.
1/8.
1/8.
Now, what is the probability of 4?
1/8.
1/8. Now, what is the probability of getting 2 and 4 at the same time? Can I?
It cannot be.
It cannot
No,
be.
cannot
It
be.
will be 0.
Mutual.
So this will be mutual exclusive. So the answer is 2/8 or 1/4. Now, odd or 6. So here now, what is the probability of getting odd?
It should be mutually
Or
exclusive.
So now, yes. So it is here. It is the probability of odd plus the probability of 6 minus the probability of odd and 6. Now, what is the probability of odd? How many odd numbers we have?
4/8.
We have 4. Bravo. Of 6. How many 6 here we have?
1.
1/8.
1/8. Now, what is the probability of getting odd number and 6 at the same time?
No, 0, miss.
There's no. Bravo. So it is 0. So I will say the answer will be 5/8. And this will be mutual exclusive.
Teacher,
Yes.
miss, you mean here odd and the number is 6.
Yes.
And when you say odd and 6. Ah, okay.
Now. Number 4. Oh, number 3, sorry. It was probability of getting odd or greater than 3. So what I have to say here? Probability
Of odd numbers
of odd
plus,
plus
yes,
the probability of numbers that are greater than 3 minus probability of odd
of A and B.
Greater than.
And greater than 3.
Yes. So how many numbers that they are odd here?
4.
4/8.
We have 4 numbers. Bravo. How many numbers they are greater than 3?
5.
5. Bravo. Now, how many numbers that they are odd and greater than 3?
Two.
There we have.
Yeah.
Odd and greater than 3.
You have 5,
2, yes,
7.
miss.
And
Two
7, 2.
numbers.
2/8.
So 4 plus 5 is 9 minus 2. So it will be 7/8. Now, here, you roll a black number cube and a white number cube. Find each probability. Now here, what did you have? Here you have an black, or let's draw them. You have a black and you have a white number cube. And you know that the number cube, it has a numbers such as 1 in each face, as you know. 1, we have 2, we have 3, we have 4, we have 5, and we have 6. And here we have the same 1, 2, 3, 4, 5, and 6. These are the sample space for each of the number cubes. Now, what is the probability of getting from the black one number 4 and from the white one number 4? Now, when you see word and, remember that I'm talking about dependent or independent. So word and, dependent or independent. If I am get number 4 from the black and number 4 from the white, are they depend on each other?
No, teacher.
No. So because of that, I will say this will be independent events. This is the first step. So independent events. So then I mean and it's mean multiply. And it is the probability of getting 4 from the black multiply by the probability of getting 4 from the white. Now then, what is the probability of getting 4 from the black? How many 4 we have on the black number cube?
1. 1/8. 1/6.
So we have 1/6 times. How many 4 on the white?
1/6.
1/6.
1/6. Bravo. So they are 1 over
2/6.
1/12. They are not, they are multiplied.
Oh, 1/12.
1/12. Yes. Now, what is the probability that if you get an even number from the black and even number from the white?
3/6.
Let's say here. Now, how many numbers that they are even? They are 3. Bravo.
3
So
over
4 or 6. How many numbers that they are even in the white?
3/6.
They have 3 numbers too. So the answer will be 9/36.
9/36.
Multiply them. Be careful. Or
Okay,
1
teacher.
over.
Teacher, in the
Teacher,
first one,
Yes, in the first one it's 12.
Yes,
it's
miss.
supposed to be 36.
Oh, sorry. Thank you. Maybe multiplied. This must be multiplied. Sorry. Is it clear?
Yes, teacher.
Yes, teacher.
Yes, teacher.
Okay. Now, the last question here. You choose a marble at random from a bag containing. So here, what did you have? You have a marble. supposed to be like this as an example. This is my marble as an example. It contains 3 yellow marbles. So we have now 3 are yellow. And 8 are red. And 4 are blue. You pick a second marble without replacing the first. So here, I take the first one and I didn't replace it. I keep it in my mind. Find each probability. Now, probability of red, then blue. And first of all, how many marbles I have in my bag here?
15.
We have 4 plus 3 plus 8.
15.
So here now. So here, how many marbles we have? We have 8 plus 4, 12, plus 3, 15. So we have here 15 marbles. Now, the first one, what is the probability of getting red? So here now, I have to choose red first, then blue. So from here, since I said probability of taking red, then blue, so I'm dealing now with dependent events. So I have to say the probability of red times, so let's say solve it here now. Number 19, probability of red times the probability of the blue after a red. Now, the probability of red. Now, how many red we have here?
8 over 15.
We have 8 red.
over 15.
Bravo. Over 15. Now, when I take a blue, when I take this red, sorry, I take it outside now. Okay? So now, I know I want now to choose a blue. How many blue we have now?
4 over 15.
We have 4
4
blue.
over 14.
Aywa, 4 over. Now, since I take the red and keep it in my hand, how many balls are left now? We have only 14.
14.
I will say it is 8 over 15 for the red times 4 over 14 for the blue after I choose the red. And the answer is 32 over 210 or 16 over 105. So this is here the first one. Now, the second one, number 19. Both of them are yellow. So both of them are yellow. It means I have yellow to multiply the probability of getting the second yellow after the first yellow. Now, how many yellow here we have?
3.
3. And how many balls we have in all?
15.
Oh, how many marbles? 15. Now, I take the yellow. Oh, I took the yellow, sorry. Let's take it outside now. Now, in the second case now, how many yellow are we have now?
2 over
We have
14.
2. Now, after I took the yellow and put it in my hand, I have 2 only. Yellow. And how many balls are left now?
14.
They are 40 because I take one of them. So we have 6 over 210 or 3 over 105. Now, let's come to it. Now, number 20. In number 20 here, yellow, then blue. So the probability of getting yellow times the probability of getting the blue after I
yellow.
took the yellow. Now, the probability of getting yellow. How many yellow here we have now?
3 over 15.
3 over
Bravo.
15.
We have 3 yellow over 15. And then how many one are blue now after I took the yellow? So when I took the yellow, let's take it outside here. So after I took the yellow now, how many blue are left?
4 over 14.
They are 4. They are the number of the blue didn't depend on the number of the yellow. But the number of the whole marbles are depends. How many marbles now are depends? Sorry. How many
14.
marbles? We have 14 now.
14.
So we say they are 12 over 210 or 6 over 105. Now, the last part here, the probability of getting both of them are red. The last
Means
one here.
probability of red.
So it is the probability of getting red times the probability of getting red after
After the first.
the
Red.
first red. Now, what is the probability of getting red?
8 over 15.
Here we have
8
only
over 15.
bravo, 8 over 15. Now, after I took the red,
7 over 14.
we have only 7. So we said 7
7 over 14.
over 13. Bravo, which is 15 over 210.
No, teacher, it's 56.
Um, sorry, 56. I add and I multiply at the same time. Okay. Is it clear?
Yes, teacher.
Yes, teacher, thank you.
If
Yes, miss. Thank you.
so if I have now this one, but it's not with you, but just to understand more. If you have now the probability of getting red, then yellow, then red, then blue. Yeah. The first one, what did I get?
8 over 15.
I
8
have
over 15.
first red. So
8
now,
over 15.
so here now we have, just a minute, let's them back. Now, I have now, I want to choose red. We have 8 reds only, so I have to say 8 over 15. After I took the red, I want to choose yellow now. How many one are yellow?
3 over 14.
3 over 15.
3 over 15
3
over 14. Bravo. Times. How many? So after I say, just a minute, please. I took the yellow now. Now then, I want to take red. How many one are red?
7.
now?
7 over
7
13.
over 13.
Bravo. 7 over 13. Then I have to choose blue. How many one are blue?
4
4
over
over
12.
12.
4 over
12. Bravo.
12. Yes.
And the answer will be 8 times 3 times 7 times 4. Now, if as an example, and I will not ask you about it, but if as an example tell you write the probability in percent, you have to divide 672 into 32,000 or 760. Then this answer multiplied by 100, you will find that, what's this? Just a minute, please. The answer will be 0. Like I'm sorry, it could, I think it could be 200%. I mean, like when I ask you to find the percent of the probability, just you have to divide these two numbers and then multiply it by 100% in order to find the answer in a percent. That's it. Do you have any question?
Teacher, and I will multiply 100 and the percent sign.
Yeah, by 100, this answer by 100, you find that the answer is 2, and then put the percent beside it.
Okay.
Okay. Do you have any question?
No, teacher. Thank you so much.